In this video, I'm going to show you 3 more examples of how to determine whether a function is even or odd with the algebraic test. And I've set up this little graphic organizer to kind of go along with the previous video. So if you haven't watched the previous video where I talked through this graphic organizer, please go back and do that before you watch this. Okay, so first we're going to start by plugging in negative x into every x in the original function. So when you do that, make sure you put it in parentheses. So we have a negative, and in parentheses, negative x cubed, all over 4 times the negative x squared plus 3. And this is the first part of the test for both the even and the odd test. So when you look at this, if you look at your numerator, if you take any negative number and you cube it, it's still going to give you a negative number. So then we have a negative, so think of this as a negative times a negative x to the third, all over. And then on the bottom, we have a 4 times, when you take any negative number and you square it, it's going to give you a positive number. So we have a positive x squared plus 3. So when you simplify it up top, we have 2 negatives multiplied together. So we have a positive x to the third. And on the bottom, we have a 4x squared plus 3. So this is going to be the form that we're going to compare to both this first box, and we're going to compare it to the second one. And we're looking to see where it matches, if it does. If it doesn't match either of those two parts, then it's going to be neither even or odd. So in this first box, up on the right hand side, we just recopy the original function. So we're looking at this, the original, compared to what we have over here when we plugged in negative x. Since these do not match, it's not even. So we need to continue the test to see if it is going to be odd. So down here, what this means, negative g of x, means take a negative 1 and multiply it by the original g of x function. When you do this, just be cautious. This negative 1 on the outside isn't going to multiply into every single term in that fraction. Think of it more as like a negative 1 over 1. So that's truly what's happening when you multiply in by negative 1. So when you multiply in, really it's just going to change the value of what's up top to be a positive x to the third. And then in the denominator, you have a positive 4x squared plus 3. That didn't change at all. So now I'm looking at this. So negative g of x compared to g of negative x. Since those two match, it's going to be odd. And if you graph it in your calculator, you can confirm that. This graph looks a little funny, but it is going to be definitely symmetric to your origin. Let's take a look at another one. Here we have f of x is equal to 7x cubed minus 5x. So we're going to start by plugging in negative x everywhere we see an x. Okay. So again, we're going to simplify this. So we have 7 times a negative x cubed. Anytime you take a negative number and you cube it, it's going to give you a negative number. So really we have 7 times negative x to the third. And then the second part, we have a negative 5 times a negative x. So it's going to give us a positive 5x. So when you simplify this first term, you can write as negative 7x cubed and then plus 5x. So this is going to be what we're comparing both in this first box and the second one. So up in this first box, I'm just going to recopy the original. So positive 7x cubed minus 5x. Compare it back to when we plugged in negative x. Those are definitely not a match. So this shows that it's not even. For the second part, the negative f of x, we're going to take a negative 1 and multiply it by the original function. Now here, since there's no fraction like there was in the last one, we don't have to worry about which terms change signs and which don't. You're just going to distribute it all the way in. So we have a negative 7x cubed plus 5x, and that's simplified. So we take this and compare it to what we got over here. These two are in fact a match, which shows that the function is odd. And if you graph it and you look at the picture, it should look like it's symmetric with the origin, so it has that rotational symmetry about the origin. All right, let's do one more. So here we have negative 4x to the 6th plus 7x squared. If you take a look at those exponents, already those exponents are even. And there's no other, I mean, it's a polynomial, so potentially it looks like this function might be even. And actually, if you take a look at the last one, for this one initially, all of our exponents were odd, so that should have been an indication that this function was going to turn out to be odd. You can't always use that as a trick, but it's kind of a nice little, it's a nice little trick to kind of lead you to what it should be, but then the algebraic test actually proves it. So let's go back to the other one. So it looks like it's going to be even, so let's see if that works out. So first we're going to start by plugging in negative x everywhere where there's an x in the original function. Alright, and so now, the biggest mistake people make on ones like this is that they see this negative x to the 6th, and if you take any negative number and you raise it to the 6th power, it's going to give you a positive number. So the mistake that people make is that they think it also changes the value of that 4, that negative 4 out front, when actually it doesn't. That negative 4 is still going to have to get multiplied in by that number that you raise to the 6th, so they're really two separate things. So that negative x to the 6th is going to turn into any negative number into a positive, which is why we write it as positive x to the 6th. We still have that negative 4 out front, which we will then multiply together. If you look at the second one, 7 times, now here, you take any negative number and you square it, it's going to give you a positive number. So simplified, it looks like negative 4x to the 6th plus 7x squared. And this is going to be what we compare it. So up here, we're just going to rewrite the original, negative 4x to the 6th plus 7x squared. These two are, in fact, an exact match. So that proves that the function is even. You don't then need to continue to do the odd test, but if you just want to see why it's not odd, if I take the original function, so negative 4x to the 6th plus 7x squared, and multiply in that negative 1, you're going to end up with a positive 4x to the 6th minus 7x squared, which when compared to that is definitely not the same, so that shows that it is not odd.
Made with Doodlecast Pro.